Hello, hope you're doing well. Last time I had an introduction into the variation from the topic that we were talking about on formula and variations. So initially we started with the formula part and then now the second part of variation. And I talked about the three types of variations. We have indirect, we have direct, and we also have the joint variation. So today we are going to have some examples on the direct variation, and kindly before I begin, please consider subscribing. Okay, so thanks. Example number one, we can see it reads, the area A of a triangle varies directly as its height h. The area is 18 square centimeters when the height is 9 centimeters. And then the question is, what is its area when the height is 8 centimeters? And then we have to find the length of the base of the triangle. So in the direct variation, whereby quantity A varies proportionately or varies directly to quantity B, this kind of relationship whereby we have one quantity or one variable and another variable whereby they are varying directly. We normally say, and we even did an example, and we saw that when we calculate the ratio of those quantities, the ratio is always a constant value. If you have several of them, maybe you have quantity A, quantity B, quantity C. So if you find the ratio between quantity A and quantity B, and then again quantity B and quantity C, the ratio will always be constant. And the symbol that is used to denote proportions, we saw it is that one. So we are going to start with example number one. We are told that A varies directly. We said this is how we are supposed to write it. So this one means A varies directly as H. And then now for us to make it, to turn it in such a way that we can do some calculations, you saw the way I was doing. I said A is equals to, you introduce a constant of proportionality, let's say K, and then your H. So to change now from this the symbol of proportion to the equal sign, you have to introduce this constant of proportionality. Okay, so the first thing is to have it like this. So you have A varies directly as H, and then now you have to change it in such a way that you have an is equal sign. And for you to have the equal sign, you have to have the constant of proportionality, the K. So we have A is equals to KH. Now we can just go directly and replace where we have A with H and then find the value of K. Once we have the value of K, then now we can go back and get and solve and answer those questions. So whenever A is 18, when A is 18, H is 9, and we know K is there, so we have 9 and then K. You see, so we have 18 and then 9K. From here you can just find the value of K, because you divide both sides by 9, and then your K is equals to 2. So you have your K is equals to 2, and you want to find the area when the H is 8 centimeters. So is 8. We've gotten our K is equals to 2, and we want to find area. We know that area is equals to K and then H, right? So A is equals to our K is 2 and our H is 8. You multiply, is equals to 16. So our area is equals to 16 square centimeters. That is the first question. Question B, or the second part of the question, asks you to find the base of that triangle. So we have our triangle like this, the right angled triangle, whereby the h is 8, right? And the area is 16 square centimeters. You have to find the base, which is here. So for you to get the base, you have to know what is the formula of finding the area of a triangle. And you know that the area of a triangle, the formula is a half base multiplied by height, right? And then you know that your base you don't have, that is what you are looking for. You have your h as 8, and you know the answer is 16. Cancel by 2, 1 by 2, 4. 4b is equals to 16, and then you can find for the value of b by dividing both sides by 4, and your b is equals to 4 centimeters. So you've solved it. The first part, using the concept of direct for the proportionality, whenever it's varying directly, and we add a is equals to kh, then you substitute, find for the value of k, and then come again when your h is 8, then find for the value of a, your area. Once you have the value for a, now go back. You have your triangle there, you know your height, and then you have to find for the value of b. Now apply the formula for calculating the area of a triangle. You know the formula is a half multiplied by base multiplied by height. Okay, so you proceed and say that you have 1/2 multiplied by the base. This is your unknown. This is what you are trying to look for. Multiply by the height, which is 8. Then you can simplify by dividing by 2 there, and then by 8 you divide by 2, you get a 4. 4 multiplied by b is 4b is equals to 16. Divide both sides by 4 to get the value of b, and then your base is 4 centimeters. So you've solved for the two. It's one question, but it has two parts, part A and part B. So for part A, it was about the area, and then for part B of the question, it was the base of the triangle. So our question 2 reads, given that y varies directly as the square of x, and that x is equals to 4 centimeters when y is equals to 16 centimeters, find the value of y when x is equals to 11. So we have x is equals to 4 centimeters, okay, and y is equals to 16 centimeters. So first of all, y varies directly as x. Y varies directly as the square of x. And then from here, we'll have y is equals to kx squared, right? Okay. Then we know y is equals to 16, while k is equals to 4. X is equals to 4, sorry. So it's a 4 squared multiplied by k. 16 is equals to 16k, and your k is equals to 1 because you divide both sides by 16 by 16. And then now you have to find for the value of y when x is equals to 11. What is y? You have to find for the value of y when x is equals to 11. So we know that y is equals to kx squared. Our x is 11 and our k is equals to 1. So y is equals to 11 squared multiplied by k, which is 1. And this is the same as 121, and you are done. It's simple as that. So I hope you followed through. Thanks for watching. Kindly subscribe and see you next time. Bye. Thanks.